So let us look at computation aspect today. So we'll present the basic of computation now. In particular, we'll discuss expressions, how to iterate over a series of values, that is iteration, and select between two alternative actions, that is selection. We'll also show how a particular subcomputation can be named and specified separately as a function. And to be able to perform more realistic computation, a vector will be introduced. So we'll be seeing selection, iteration, function, and vector. This is the overview of this session. What is computable? Because when we are talking about computation, the certain question is what is computable and how best to compute it. Then comes the abstractions, the algorithms, the heuristics, and the data structures. The language constructs and ideas, that is sequential order of execution, expression and statement, then selection, iteration, functions, and vectors. These are the overview. And you are aware of most of the thing which we'll be discussing. You know about this arithmetic, means A plus B into C. Here into is shown by the star because we need something from the keyboard, that is this is the star. And you also know how to select, that is if I present a sentence for you, if this is true, do that, otherwise do something else. That is if then else. You know how to iterate also, because all these things you know. We are just presenting it in the form of coding, but the essential idea you know already. Means do this until you are finished. Write it 100 times. Do that 100 times. These are the iterations. And you also know about functions. Means go ask Joe and bring back the answer. Or say, hey Joe, calculate this for me and send me the answer. So what we are going to show you today is mostly just vocabulary and syntax for what you already know. This you know, and how we present it in C++ language that we are going to see today. Computation means you are inputting some data, getting some output, and in between code, often messy, often a lot of code. So the input data is changed to output data with certain computation. So input is normally from the keyboard or the file or any other input devices or the programs as well, and other parts of a program. While this computation, what our program will do with this input to produce output, in between we have this whole computation aspect. Then the output, this is the output. That output can go to the screen, to the file, to other output devices, to other programs, and also to other parts of a program. So in computation, our aim is to express computation correctly, simply, and efficiently. There are various ways, so we need to choose that way which suffices all these three aspects. One tool is called divide and conquer. That means to break a big computation into many little ones. The other is abstraction, means provide a higher level concept that hides the detail. Then comes the organization of data, which is often the key to good code, means what will be the input and output formats, what will be the protocol we are going to use, and the data structure. Very important, the data structure. We need to note that the emphasis on structure and organization. You don't get good code just by writing a lot of statements. Your 1,000 codes may be waste, but maybe 10 or 15 line of code may do the same similar task. So go for the quality, not the quantity. So our feature, language feature, means each programming language feature exists to express a fundamental idea. For example, addition, multiplication, if statement, if else statement, that this is called the selection statement, then while statement, for statement, do while statement, these are the iteration. Fx means this function f working upon some input x, this is the function operation, and we combine language features to create these programs. Let us see the expressions. And int length is equal to 20, the simplest expression, a literal here, which is 20. So length is given a value as 20. This is the simplest expression. So we employed length as a variable of time integer to contain the value of 20. In the similar fashion, int width is equal to 40, same logic for this. Then int area will again be an integer, length from here, width from here, and a multiplication is performed on length and width, and average can also be computed, means length plus width by 2, addition and division together. This is multiplication, this is assignment, this is addition, and after that division. So the usual rule of precedence apply. What does it mean? It means first this one to be computed, means BODMAS type, and first this has to be computed, and not like this. This is wrong. So the normal precedence rule of mathematics would apply, and if in doubt, try to parenthesize. This is the best idea. Use parenthesis, parenthesize. There will be no doubt, not in your mind, neither for the compiler also. So if complicated, again parenthesize. Don't write absurdly complicated expression like this. This is very complicated. Try to cool it down, write what is required and what is understandable. Choose meaningful names. Expressions are made out of operators and operand. Operator, what are operator? They specify what is to be done, while the operands, they specify the data for the operators to work with. So operator will work on operands. If we start with Boolean type, that is bool, it can be true or it can be false. This is equality operator, means double is equal to will be equal to equal, not equal to will be equal to not equal. So this will be for not equal, this will be for equal. The logical operators, double and, double pipe for or, exclamation mark for not. And relational operator, this is in sign, and less than and greater than, or less than equal to and greater than equal to. These are two, or rather four relational operators. Character type, char, integer type, short, integer and long. So arithmetic operators that will work upon integers will be plus, minus, into, division and remainder. While floating point operation, again plus, minus, multiplication and division, remainder will not be there. Concise operators. For many binary operators, there are equivalent more concise operator like this. If we wish to write A is equal to A plus C, then this will be equal to A plus is equal to C. This is called the shorthand form. Again, A is equal to A into C, so why to write A again and again? Don't write this. Delete this, and this will be more than enough. Just you have to change the position of multiplication and is equal to C. Multiplication is here and the equal to sign is shifted rightwards. Plus plus A means A plus is equal to 1 or A is equal to A plus 1. So A is equal to A plus 1 will be equal to A plus is equal to 1. This will be equal to plus plus. So try to use this, and we'll be often be using this only. These are concise operators. They are generally better to use because the code will become clearer, expresses an idea more directly. Now coming to statements. A statement is an expression which is followed by a semicolon or a declaration or a control statement that determines the flow of control. For example, A is equal to B, assignment. Double D2 is equal to 2.5, assignment. If X is equal to 2, Y is equal to 4. This is again a statement because what? We are selecting something. While again a iteration. This is a whole statement. Integer average is equal to length plus width by 2. This is again a statement. Return X is also a statement. So you may not understand all of these just now, but when you will program, you will. So coming to selection, sometimes we have various options and we need to select one of them. For example, suppose we want to identify the larger of the two values. we can do this with an if statement. How? If A is less than B, then the larger number will be B. But if this condition does not suffice, or this condition is false, then we'll go to else. So this number will be, the maximum number will be A. So that its syntax goes like this. If the condition will give the value as true or false, we'll do statement 1, else statement 2. An iteration, again the second one is while loop. For example, let us see the world's first real program running on a stored program computer, that is David Wheeler, Cambridge, which was calculate and print a table of squares 0 to 99. So it started with int I equal to 0 while I is less than 100, C out I, square I. This while is the iterator. It will start from 0 and go up till 99. And actually, it was not written in C++. Iteration, while loop. What we want to emphasize here is, first of all, the loop variable. This is our loop variable. I. This is initializing a control variable. Loop variable or control variable are equal or are similar. So initialize the control variable, terminate, or termination criteria has to be there because while has to come outside. For that, I less than 100, which is when this is false, the loop will terminate. Then incrementing the control variable like this. This is I and control variable, or you can say loop variable, we increment it. And once we increment it, then something has to be done. This is what it has been done. There is one another famous and most widely iteration loop, which is for loop. So you can collect all the control information in just one place at the top, where it's easy to see. One line, this is initialization, this is condition, and this is increment. Or this is initialization, this is termination, and this is increment. Same stuff which we have done just by while can be easily converted to few lines and in the similar fashion, clean fashion, by for loop. But what was square I? This is a call for the function, because here also we are calling square I. In this while also we are trying to return the value from square I, but where exactly is square I? The square I, this is a call of a function square, which is like this. We define a function when we want to separate computation, because why? Actually, C was function based or structured language. So this idea came from that only. The part should be logically separate and it should make the program text clearer by naming the computation. And is useful in more than one place in our program. We can use it again and again. And it eases the testing. It facilitates the testing, distribution of labor and maintenance. This is the control flow. How this control goes from and where. From main it starts I equal to 0. Then it goes to while equal to 1 less than 100. Then it is goes to square I. This square I will take you to this function in square. This will go inside, return xx means square, and then again it will go to the iteration, and this will go on. This loop will go on until 100 is reached or 99 is reached. Means after 99 it will come out. This is the control flow. So our function, which is the square function, it returns x into x, which is, this is an example of, this is return type, int is a return type. The function name is square. The parameter list int x. So we use each parameter in code and we return some value. So this is return. What we are returning? X into x means x square is returning. One more example. Where we looked at code to find the larger of two values. Here we do a function that compares two values and returns the larger value. So if a is less than b, this is max. The function name is max. The values are a and b. If a is less than b, we return b. That means the other one, and else return a. This will return the larger one. So if a is less than b, b will be larger. So B will be the max. And in the similar fashion, if this does not hold, it will return A. So in this case, we just use this max function in the calling function. Just we pass 7 and 9, the answer will be 9.